Dominica State College Math 1-to-1 Final Assessment, Section A, Practice Questions. It says, John claims that the average time students spend in the library is more than 70 minutes. You are given the task of testing the above claim by using the following statistics. You have a sample mean of 72 minutes. You've got a standard deviation of 1.7 minutes and a sample size of 81. And a z-critical value of negative 2.33. So let's go to Unit 9, weekly notes number 9, to get some help as to how to complete this question. Unit 9 is located in the Google Classroom class code CI3QYBO. So you log into there, you join this Google Classroom and you go to classwork, and you scroll down and you go to the weekly notes. You have it in Word, PDF, PowerPoint, and video format. We can take a look at the PDF format. Click on weekly notes number 9. This is the unit that deals with hypothesis testing. And we are going to look for z-test for mean, an example of z-test for mean. Here are the steps to perform any hypothesis test using the classical or critical value approach. So here you've got 8 steps. Now there is another document in that same Google Classroom that deals with the steps for the critical value approach, specifically for z-test for mean. So we can take a look at that. But also there is an example in this, there are examples in this unit that we can also look at. Example 9.1 deals with a z-test for mean, a two-tailed test. Example 9.2, z-test for mean, a left-tailed test. Example 9.3, a z-test for mean, a right-tailed test. Now also, if you go to Math 1-to-1 course information and you go to Math Interest in Reading Part 1 and you scroll on, you will see a document called Update 1, the full circle, okay, of statistics, of a statistics project. All right, and if you scroll down in this very interesting document, you will see some information on hypothesis testing. And here you have the steps for a critical value or classical approach for z-test for mean. So we can use that because this is tailor-made for specifically for a z-test for mean classical approach. So we first have to translate the stated hypothesis in mathematical form, and to use that we've got to use this table here. So let's go to the worded hypothesis in this example in the practice question. So in this example, the keyword there is more than, So we've got to look for the translation, the symbolic translation for is more than. So here is the translation for is more than, the mean is more than. So this is the symbol for me is more than, the inequality sign pointing towards the right, reading from left to right, and actually an alternative hypothesis. So this is the translation for is more than. Now the second step is to identify whether it is a null or an alternative. It is an alternative because is more than doesn't carry the equal sign. And third, we've got to complete the pair. We've got to include the null and the alternative. So the null will be less than or equal to, or you can also put just equal to for the null. It's common practice to just put equal for the null. No matter if it's left tail, right tail, or two tail, you can just put equal for the null. So we have steps numbers 1, 2, and 3, the translation of the claim to symbolic form. It was an alternative. The completion of the pair of hypotheses. For the null, you can just put equal, no matter even though it's right, left, or two-tailed, you can just put equal as common practice. And the pair has been completed. So let's look at steps numbers 4, 5, and 6. Step number 4 says to sketch a normal curve, a bell-shaped curve, because it's a z-test for mean. Step 5 says to locate and shade the critical region. Okay, so a z-test for mean can be either one tail or two tail. One tail could be left or right. Okay, two tail, the rejection region on both sides of the curve. And to know where the rejection region is, you got to focus on the sign of the alternative. So it says, remember, for the z-test for mean, the rejection region will always follow the sign of the alternative statement. So if the alternative is pointing towards the right, it will be a right tail. If the alternative is pointing towards the left, it will be a left tail test. If the alternative is not equal, it will be a two tail test. So I think we've got a right tail pointing for the alternative, so we've got a right tail test. And step number 6 now says to place the critical value on the critical point. So our critical point will be on the right. So this is the appropriate curve for the test that we have. So we can take a snapshot of this curve to put on our answer paper. So here we've got our curve, and our critical region is on the right because our alternative is pointing towards the right. Our critical point is on the right, and our critical value, which is provided for us, is negative 2.33. But because we are on the right side of 0, because in the middle here, we've got 0. Okay, so therefore now we've got to drop the negative sign. So our critical value is 2.33, because any number on the number line on the right side of 0 have to be positive. So here we have steps number 4, 5, and 6. The curve, the critical region on the right, and the critical value on the critical point. So we're moving on to step number 7. It says to calculate the test statistic, okay, using this formula that we have here, and using the statistics that were made available. So here's the formula to calculate the z-test statistic. So here's the formula, and here is the statistics that we've got to use to calculate the z-test statistic. So the z-test statistic is equal to the sample mean x bar, which is 72, subtract the population mean, which is 70, it's in the hypothesis, divided by the standard deviation 1.7, which is in turn divided by the square root of the sample size, the square root of 81. So 72 subtract 70 is 2. And 1.7 divided by the square root of 81. The square root of 81 is 9. So we have 1.7 divided by 9 is 0.19. So we've got 2 divided by 0.19. That's equal to 10.53. So now we're moving on to step number 8. It says plot the test statistic on the distribution curve. So you must look at the value of the critical value in order to plot the test statistic on the correct position in the number line or on the number line on the curve. So we have to plot 10.53 on the number line, and we have to take a look at where 2.33 is located. That's 0, that's 2.33. So 10.53 is more towards the right of 2.33. So therefore now our test statistic is in the rejection region, as we can clearly see. So now we move on to step number 9. It says decision time. You reject the null if the test statistic is located in a critical rejection or shaded region. or you do not reject the null if the test statistic is located in the unshaded region. There are two errors that can be made. We'll talk about it after. The type 1 error occurs if the null is rejected and when it is true, and the type 2 error occurs if the null is not rejected when it is false. So do we reject the null or not? We will know according to where the test statistic has landed. If the test statistic is in the critical or rejection or shady region, then we reject the null. If not, we do not. So let's see where our test statistic has landed. The test statistics of 10.53 is in the rejection region, as you can see. So therefore, we have to reject the null. So our decision is to reject the null. So since we have rejected the null hypothesis, we may have committed a type 1 error. We will not know because we are using the statistics to make our decision. Okay? And as it says, if the null is rejected and it is true, then a type 1 error may have been committed and we have rejected the null. So it could have been true. Okay? Now, step number 10, it says conclusion time. If the null is rejected, then the alternative statement is the conclusion. If the null is not rejected, then the null statement itself is the conclusion. So you always have to remember that you will start the test with two statements, the null and the alternative. After the test is done, only one will be the conclusion, and you have to write it in worded form. So we have rejected the null, so therefore the alternative statement is the conclusion. So here are the two statements, the null and the alternative. The null is saying that the mean is equal to 70. The alternative saying no, the mean is more than 70. We have rejected the null, so therefore we have to conclude that the mean is more than 70, according to what the alternative statement is saying. So based on the data, the average time that the students spend in the library is more than 70 minutes, which is in accordance with the claim, because that's what the claim is stipulating, that the mean is more than 70 minutes. And that's what we end up concluding because we got an average of 72 in the test statistic. The X bar, the sample mean is 72. So it appears that 72 is significantly more than 70 minutes according to this test. So always remember you will start the test with two statements and one of them will be the conclusion, either the null or the alternative. So if you reject the null, then you are left with the alternative. If you do not reject the null, then you keep the null as the conclusion. We have rejected the null because the test statistic is in the rejection region. So we conclude with the alternative statement, and here you have it. So here you have an example of a C-test for mean. That's the first question in the practice question using the critical value approach or the classical approach.